Your brain is not a fixed organ. This is the most important thing neuroscience has learned in the last 30 years, and it is still not common knowledge. Most people walk through their lives assuming the brain they have at 40 is more or less the brain they will have at 60, that the mental sharpness they feel, or do not feel, is simply what it is, a given, a ceiling. That ceiling does not exist. The brain is plastic, not in the material sense, but in the scientific one. Neuroplasticity is the documented capacity of the brain to physically reorganize itself in response to experience, challenge, and deliberate practice. New connections form. Existing connections strengthen. Regions associated with attention, memory, and executive function can grow measurably denser in response to the right inputs. This is not a metaphor. This is observable under a scanner, and the inputs that drive this reorganization are not mysterious. They are specific, repeatable, and available to you right now. What follows are 7 exercises. Not puzzles, not games, not passive entertainment dressed up as brain training. These are activities with documented neurological effects, each targeting a different aspect of cognitive function. Each one asks something real from your brain, and that demand is precisely the point. Exercise 1. Dual N-back training. In 2008, a study published in the Proceedings of the National Academy of Sciences by researchers Suzanne Yagi and Martin Bushkuhl produced one of the most controversial and closely studied findings in cognitive neuroscience. They demonstrated that a specific working memory task, one that required participants to track 2 simultaneous streams of information and identify when a stimulus matched one that occurred n steps back in the sequence, produced measurable gains in fluid intelligence. Not just memory, fluid intelligence. The capacity to reason through novel problems you have never encountered before. The task is demanding. You track a sequence of letters and a sequence of spatial positions simultaneously, and you must identify when the current letter or position matches the one from 2, 3, or 4 steps earlier in the sequence. Your working memory, the mental workspace where you hold and manipulate information in real time, is pushed to its absolute limit. This matters because working memory is the foundation of nearly every complex cognitive function. When you follow a long argument, when you hold the thread of a conversation while formulating your response, when you read a difficult text and track its logic across pages, you are running on working memory. Strengthening it is not a narrow gain. It ripples across everything your brain does. 15 to 20 minutes a day. Multiple free versions exist online. The discomfort you feel while doing it is the signal. That is the training load. Exercise 2. Deliberate reading. Not reading for pleasure, though that has its own value. Deliberate reading means choosing texts that actively resist you. Material that is above your current level of fluency. Philosophy. Dense history. Scientific literature outside your field. Material where you must slow down, reread, hold multiple ideas in suspension simultaneously, and track an argument across pages rather than consuming information in fragments. Neuroscientist Maryanne Wolf at UCLA has spent decades studying what happens to the reading brain. Her research shows that deep reading, the kind that requires sustained attention and inference, activates the prefrontal cortex, the parietal lobes, and regions associated with empathy and perspective-taking in ways that surface-level reading does not. The brain is building more complex representational networks. It is learning to hold more structure in mind at once. 20 minutes of genuinely difficult text per day. Not skimming. Not reading while doing something else. Sitting with it until it opens. Exercise 3. Physical exercise. This one is not optional. The evidence connecting aerobic exercise to brain health is now so consistent and so robust that it is difficult to overstate. A landmark study by researchers at the Salk Institute found that regular aerobic exercise dramatically increases the production of a protein called brain-derived neurotrophic factor, or BDNF. Neuroscientist John Rady at Harvard Medical School has called BDNF miracle grow for the brain. It promotes the growth and survival of neurons, enhances synaptic plasticity, and is directly linked to improvements in learning, memory, and mood regulation. The hippocampus, the region most critical to memory formation and spatial navigation, physically grows in volume with regular aerobic exercise. Studies using brain imaging have shown measurable increases in hippocampal volume in adults who exercise regularly compared to sedentary peers. This is not a metaphor for feeling better. This is tissue. This is biology. 30 minutes of moderate aerobic activity, 4 to 5 times per week. Running, cycling, swimming, brisk walking. The heart rate elevation is the signal. That is the mechanism. Exercise 4. Meditation and focused attention training. Neuroscientist Sara Lazar at Harvard Medical School published a study in 2005 that showed experienced meditators had measurably thicker cortical regions in areas associated with attention, interoception, and sensory processing. Not just functionally different, structurally different. The practice of directing and redirecting attention had left a physical mark on the tissue of the brain. Focused attention meditation, the practice of resting attention on a single object, typically the breath, and noticing when it wanders and returning it without judgment, is a direct training of the attentional control network, the prefrontal cortex, the anterior cingulate cortex, the structures that allow you to choose where to put your attention and hold it there. Every time your mind wanders and you bring it back, you are doing a repetition. A single, clean repetition of the mental movement that matters most in a world engineered to fragment your focus. 10 minutes a day is enough to begin. The difficulty is not a problem to be solved. It is the exercise itself. Exercise 5. Learning a musical instrument. Playing music is one of the most neurologically complex activities a human being can perform. It simultaneously engages the motor cortex, the auditory cortex, the visual cortex, the cerebellum, and the prefrontal cortex. It requires sustained attention, fine motor coordination, real-time error detection and correction, and the integration of multiple sensory streams into a single coordinated output. Neurologist and musician Oliver Sacks spent decades documenting the relationship between music and the brain. His research and clinical observations consistently showed that musical training produces some of the most robust structural changes in the brain of any known activity. The corpus callosum, the bundle of nerve fibers connecting the two hemispheres, is measurably larger in trained musicians. Auditory processing is enhanced. Fine motor control is enhanced. And crucially, the benefits transfer. Musicians outperform non-musicians on a range of cognitive tasks that have nothing to do with music itself. You do not need to perform. You do not need to become good quickly. The struggle of learning, the reaching for coordination that is not yet there, the slow building of a skill from nothing, is precisely where the neurological work is happening. Exercise 6. Free writing and expressive journaling. Psychologist James Pennebaker at the University of Texas at Austin has spent 30 years studying the cognitive and psychological effects of expressive writing. His research consistently finds that the act of writing about difficult or complex experiences, of putting language around thoughts and feelings that have not previously been articulated, produces measurable improvements in cognitive function, immune function, and emotional regulation. Writing forces the prefrontal cortex to organize, sequence, and evaluate information in a way that unstructured thought does not. When you write, you cannot hold contradictions simultaneously without noticing them. The act of putting language to experience forces a kind of cognitive coherence that passively thinking about something does not achieve. You are essentially running your own experience through a structured processing filter. 15 to 20 minutes of unfiltered, uncensored writing about whatever is genuinely occupying your mind. Not a diary of events, an exploration of your actual thinking. The more honest and the more difficult the material, the more cognitive work the brain is doing. Exercise 7. Sleep. Your brain is plastic. It is waiting to be shaped by what you ask it to do. The question is not whether it can change. The question is what you choose to put it through. Start with one of these. Do it consistently. Do it until it is difficult, and then do it a little longer. The discomfort is not the enemy of the exercise. It is the exercise itself. The brain you have in 10 years will be built, in part, from what you choose to demand of the brain you have right now. Your brain is plastic. It is waiting to be shaped by what you ask it to do. The question is not whether it can change. The question is what you choose to put it through. Start with one of these. Do it consistently. Do it until it is difficult, and then do it a little longer. The discomfort is not the enemy of the exercise. It is the exercise itself. The brain you have in 10 years will be built, in part, from what you choose to demand of the brain you have right now. Subscribe to Psych Mind Inc. if you want more of this. We will see you in the next one.